Hello and welcome everybody to today's showcase. Very happy to see so many of you here today with us once again. And so I'll just let everybody join. It takes a few seconds. And in the meantime, I'd like to thank Ashish Saxena for joining us today as well. Hello, Ashish. How are you?
I'm fine, sir. Thank you for giving me the platform to talk about the topic.
Yes, it's a very hot topic. Storage. It's
Yeah.
really something that is in everybody's minds nowadays, and yeah, for understandable reasons. And today is even more special actually than just talking about storage. We're going to be doing a little bit of focus on lead acid storage, because of course lithium is very popular. Everybody talks about lithium, but today here, Ashish, you're also here to tell us a bit more about lead acid, the benefits, the truth, the myth, and so we'll be talking about this today. So before we get started, I would like to quickly share a few slides with you. So yes, we're going to be discussing about debunking myth about lead acid batteries, as I just mentioned. Our lead speaker today is Ashish Saxena, which I will introduce in a few moments. Before we get started, and for those of you who have already followed us regularly, you know this slide. It's the housekeeping slide. First point, yes, of course, the presentation and the video will be shared with you, as well as the recording. So don't worry about this. No need to take notes. Just sit back, relax, and submit your question to Ashish so that we have an interesting Q&A section at the end. And then also, the best way to share your questions is to use the Q&A option at the bottom of your screen. That's really for submitting a question. However, if you want to interact with other listeners for today, I invite you to use the chat option. And this is really like the right option to say hi and to share some contact details and ask some questions to other listeners, and the Q&A to share your questions to Ashish. Ashish is the General Manager, Asia Pacific and Africa of Eastman. Eastman is one of the world leaders in storage solutions, company based out of India, but really active throughout the globe. And yeah, Ashish really has like a wealth of experience when it comes to storage, more than 10 years in this industry. Previously worked with companies like Microtech, Asia, Suzlon, and now he's really like in charge of the general activities for Eastman in our region, the African region, but also Asia Pacific. And his expertise is really into marketing and business development, and of course international dealership, because that's an important part of the activity when it comes to supplying equipment in vast regions like this. And today, as I said, Ashish will be telling us about the fundamentals of lead acid storage, and also about the latest trends, the pros and the cons of this technology, and where it is best fitted, and maybe less also. And before I hand out the word to you, Ashish, I will be playing a little video that you've shared with us, just to give us a general introduction about the technology.
Sure.
Battery is completely sealed, maintenance-free battery. Zero maintenance required in Eastman T-Gel battery. Comes with spillage-proof gel electrolyte, tubular gel battery USPs, fumed silica gel, leak-proof valve, antimony-free alloy, high-pressure die-cast spine grids, supplied in ready-to-use condition, hassle-free transportation, advanced gel German technology. Deep discharge, higher cycle life due to antimony-free alloys. High-pressure die-casted spines provide less corrosion and higher cycle life. Low electrical resistant and high porosity corrugated silica material increases electrical performance. Improved woven gauntlet gives higher material utilization and higher capacity. Optimized negative paste recipe for faster charge acceptance. In Indian climate condition, normal battery performance may vary, but in Eastman gel battery, zero impact of climate change. Home UPS solar batteries are environment friendly. Eastman gel battery have world-class certification like IEC, UL, CE certification. Eastman gel battery made with advanced technology and machine who match with world-class standards.
There we go, Ashish. And this is already the slide from the end of my presentation, so I'll stop sharing. But very cool little video there, especially I personally like the animation to see what's inside the battery and to see how it is structured. And there was a lot more information, some technical, some more commercial, and maybe now would be the right time for you to tell us a little bit more about the company, about the solutions, and also about how you see the benefits and the best application cases about this topic on storage.
Sure. Good afternoon, ladies and gentlemen. A big thank you to Mr. John for inviting me here today. And I'll just quickly inform you about what we do. Eastman has been in the solar industry, energy storage business since 2002. We come with a track record of over 20 years in the industry. And we got into the lead acid battery business as we saw that there is a big scope where we can bring in cost effective economy range, high cycle life, high performance energy storage systems or solutions to people in across Southeast Asia, Africa, and some parts of Latin America. um, so specifically talking about the lead acid battery technology, as everyone would be aware, it's been around for over 100 years, and it's a well-proven technology that's constantly being upgraded by manufacturers like ourselves, who invest in upgrading the technology and focusing on how to increase the performance per cycle and also lower the cost per watt that basically comes out of the energy storage system. So for larger off-grid systems, which I'm sure many of us would be involved in, the lead acid or lead gel batteries are still one of the most trusted options, and if correctly designed, can typically last over 10 to 15 years. Even longer if there is a proper battery management system or a BMS that is installed along with it. So unlike lithium-ion batteries, lead-acid batteries, do not have a specific cutoff point at a certain depth of discharge. So even in an emergency situation, they can continue to provide power until the voltage reaches the inverter or the power backup cutoff. So the early lead gel acid battery is basically, I'm sure you understood what the lead gel is. It's basically the same thing. It's the liquid electrolyte is mixed, blended with fumed silica and treated under specific conditions so that the electrolyte inside the battery comes into a thick consistency. Something very similar to your hair gel that you might use on your, to style your hair. The same consistency gel is inside the battery. Now, what this does is it locks in the electrolyte that is inside the battery and avoids it from evaporating. So there is very almost negligible moisture loss. The retention is almost 99% higher than compared to AGMs or conventional flooded batteries. That basically allows it to have completely sealed maintenance free characteristic. You don't need to bother about it ever. So the gel battery was basically brought into existence by Sonnenschein. They are basically the patent holders of this technology based in Germany in the 1970s. And since then, they have evolved quite a lot by use of different types of upgraded materials. And from time to time, usually every 5 years, there is an upswing in the cycle life of the lead gel battery by at least 30 to 40% due to the technological upgrades. So the design of tubular gel basically would give you higher tolerance and higher temperature control by using advanced polymers in the valve design. It's basically a VR relay design, but because of its usage of advanced polymers, the valve basically allows for higher temperature tolerance, meaning it can operate well within its rated parameters from temperatures ranging from, let's say, -5 degrees centigrade, the average temperature in Northern America or Russia, to +55 degrees centigrade, which is the average operating temperature in most countries in Africa or sub-Saharan nations. And there's a high moisture retention by use of ethylene and polypropylene monomer compounds. There's a tubular plate construction. Now, this is the main difference between standard AGM batteries and a tubular gel battery. Because of the thickness of its plate, which ranges between 2.2 mm dia to in excess of 2.5 mm dia, depending upon which variant it is, allows it to have a significantly higher cycle life compared to the AGM. We'll get to how much exactly later on in the later slide. So as you notice, there is a calcium use of calcium and in the plate construction that gives it higher life and strength. There's a use of high grade special polymers in the separator for increasing the intercell osmosity, and fumed silica gel that allows it to retain moisture. So if you talk about the maximum daily depth of discharge allowed between lead acid or lead gel and lithium ion, yes, it does give you a higher rated capacity, available capacity. It can be discharged up to 90% of its capacity. And in comparison, the lead gel, the advanced model, the ones which are in circulation in the market in 2020 and 2021 onwards, they are capable of discharging up to 70%. So there's a difference. We have managed to basically narrow down the difference in the available depth of discharge capacity by just 20%. And in the couple of coming years, in the next 2 to 3 years, this will also be bridged. So the depth of discharge allowed on lead acid or lead gel batteries will be nearly similar to the lithium ion one, while keeping the cost at least 30 to 40% less. So if you talk about the usable capacity and the operational parameters, the lead gel basically gives you the advantage of being compatible with most inverters. Probably 95% of the inverters in the market are compatible with the tubular gel batteries. It is a safe and a very low risk investment. I'll come to it later on. The recyclability of the battery is very easy. You do not need to invest much of your manpower or your funds into disposal of this type of battery. It is maintenance free for life. It has a very low self discharge. That means longer storage time for you until you need to use it in your projects. And it is long lasting due to its ability to dissipate heat. And the cycle life ranges between 2500 cycles at 50% DOD up to 3500 cycles at 50% DOD, depending upon where exactly it is used. So currently, most major manufacturers have this analysis that indicate where exactly you should be using lithium ion as compared to tubular gel type batteries, because the lithium ion battery has a 28% higher lifetime cost when compared to a lead gel battery in moderate climates, which have temperature range of between 30 to 35 degrees centigrade. So this is where the gel batteries come in, as they close in this lifetime cost gap by having extreme temperature tolerances and performing their at near about their rated cycle life in spite of being in high extreme temperature climates. So why exactly you would want to consider lithium is, let me just tell you what exactly are the disadvantages of having lithium in your project. The major ones are that at high temperatures, I'm sure everyone must have experienced this at one point. If the ambient temperature exceeds 45 degrees centigrade, the lithium ion or lithium polymer batteries are very prone to getting shut down if the ambient temperature exceeds 45 degrees. And also they can shut down if it is below 5 degrees centigrade. In extremes of climates, it can shut down very easily and it is prone to BMS circuitry failures. That's why it needs a very well-designed BMS battery management circuit to be operational at all times, which comes inbuilt on the battery. And because it needs a BMS system, it is very prone to supply disruption from its manufacturers. As you might be aware, it is ongoing even as we speak. There's a big disruption in the market because the circuitry which is required to be installed on the lithium polymer battery is in very short supply from China. So this basically affects people like us because when we need the battery for our projects, it may or may not be available due to the BMS systems not being available. And coming lastly to it, the lithium-ion battery is very sensitive. It needs to be installed with the correct compatible inverter. If it is not compatible or in sync with the inverter, it will almost always fail, not give the desired capacity output. Coming to the battery cost and life and operational comparison.
Ashish, you need to guide me because your slides were not showing, so I'm showing them on my side, and you just need to guide me for which slide you want me to show.
Okay, there's a cost comparison. There's a blue table. I think on the third or fourth one.
This one?
Yeah, this one.
Yeah.
Yes. So this should give everyone an idea about why they should install tubular gel as compared to lithium, or where in which projects you should go for lithium ion as compared to lead acid or tubular gel type. If you talk about the energy density, yes, the lithium ion far outweighs everyone else in this table. But it depends upon what exactly are your project requirements. And the most important part, the cost involvement that you need to invest upfront is, as you can see, the cost per watt for the tubular gel battery is as on date. These are average prices taken as per market estimate. $55 is the cost per watt for a tubular gel battery as compared to the lead acid and the lithium ion. So you can see why it remains the cheapest and the most favorable option. If you talk about cycle life at 50% DOD, as of right now, the 2020 models, onward models, they are rated at 2000 plus cycles at 50% DOD, as compared to the VRLA, which remains at average 900 to 1000. And the lithium one, which is, yes, it is higher at 2900 at 80% DOD. So at 50%, this would be somewhere around maybe 4000. It is near about double, but you need to see the cost involvement also. So as I said, the temperature sensitivity. Yeah, so this due to the advanced polymers used in the tubular gel battery, the the capacity degradation that happens in the battery is reduced to a great extent by almost 80%. So for every degree that goes above 35 degrees centigrade, the capacity will degrade only by 0.11% in the tubular gel. While in the VRLA lead acid, it degrades significantly over 3 to 4%. And in lithium ion, it nearly goes down by 50 or 60% if the temperature is above 45 degrees centigrade. The below numbers are about the efficiency. So you can see how close the gap is between the tubular gel and the lithium ion. And as I said, in the coming maybe 4 to 5 years, this gap will more or less be closed. Okay, can we move on to the next one? I think, yeah, we've covered this. So coming to the last aspect, the safety and the environmental impact. Now, I'm sure all of us handling projects in the solar industry, you would be aware about the thermal runaway phenomenon that is there in the batteries if they're not monitored or installed correctly. Now, both technologies, lead acid and lithium cells, are capable of going into thermal runaway, and they can emit dangerous fumes, but it is common for both. But the likelihood and consequences of an event, that this happens with the lithium-ion battery is much higher, as you would see with several cases in many. You would also recall the Samsung, mobile fiasco that happened. So that was primarily because of the circuit, the BMS circuit, not being configured correctly and being installed into millions of cell phones, that resulted into spontaneous fire in emitting from the mobile phone. So this is how prone lithium ion battery is if it is not installed professionally, if it has faulty circuitry installed, or if it is not in sync with its inverters, it is very prone to very violent explosions. And talking about the environmental impact, the lead gel battery essentially is similar in handling or recycling to lead acid. It is actually easier and cost effective to recycle it because there is a proper infrastructure and well matured industry that is into recycling of the lead gel battery. As compared to the lithium, it is still in its infancy stage, and anyone who is into large scale lead, lithium-ion battery projects will always have to invest a bomb into recycling or disposing of it, because the infrastructure required to recycle lithium is not present in most of the continents as on date. Only the developed nations like North America or maybe China have full-fledged lithium-ion recycling facilities. So this is something that basically holds back the investor into lithium by locking in their funds that would normally go into project financing. I hope this has given you a good idea, Mr. John, or I think that's the end of it. Yeah.
It has given me a very good idea, but I hope it has also given the listeners a good idea. Plus, also, I hope that it's sparking some additional questions. We have already received some questions, and I would like to share them with you, Ashish. And of course, I mean, some of those questions require a very complete and lengthy answer, but the idea is to be able to address as many questions as possible right now. So I'll ask you to keep some answers as concise as possible. If there's really like longer things to address, we will share your contact details and the listeners' contact details so that you can take it after today's presentation. I would like to start with a question of mine first. I'm very impressed about what you said in terms of the DoD, which is like significantly improving and catching up with DoDs that are similar to lithium. Maybe I'm naive, but I thought, lead acid and gel batteries had reached a certain level of maturity and their DoD was what it is. How come there is such a margin for improvement right now? Has anything special happened for this suddenly to be possible?
Yes, sir. So see, there are three aspects in constant research and development of the tubular gel type of battery. The major countries that are involved in development are Germany, France, China, and India. So these are the ones where most of the consultants or industries are there for research and development into it. So what they do is they focus on constantly identifying new additives, chemical additives that increase the strength of the plates inside. It's like the battery plates inside. That gives it a higher cycle life. Then there is how to increase the intercell osmosity. Therein comes the separator, the use of advanced polymers in the separator that allows for increase of rotation of the electrolyte inside. And the third is the construction or the use of the plate construction, that allows for higher retention of moisture and higher retention of higher tolerance of the temperature environment. So by developing new chemical additives, new design technologies for these three aspects allows the battery to be upgraded mostly on a once in every 2 to 3 years. So we are currently on the fourth, or maybe you can say fifth generation of the tubular gel type of battery. The first generation was developed by Sonnenschein in Germany, and from there on, manufacturers like ourselves and many others across the world, they keep developing and working upon it. And every time someone comes up with an improvement, they file a patent and make prototype to implement it and see how the cycle life compares to the best lithium-ion polymer type of batteries.
Thank you very much. And for all clarity for the listeners, Eastman specializes exclusively in tubular gel batteries or also manufactures traditional lead acid batteries?
So I think we can address some questions. I see there are 8 of them.
Yes.
Should I?
I was actually asking one of them to you. Somebody's asking a bit more clarity in terms of what your company manufactures. Are you exclusively focusing on tubular gel, or are you also manufacturing traditional lead acid batteries? Because there was some misunderstanding about this.
Oh, okay. So what we do is we basically have an entire range of the lead acid battery. So tubular gel is just an advanced version of the lead acid. Mm-hmm. As you might understand, it's basically mixed with fumed silica and some chemical updations that allow it to have a maintenance-free thing. So what we have is a conventional flooded battery that is, yes, it is more economical and cost-friendly. And most of the population of India and Southeast Asia prefer the conventional flooded because it's easy on the pockets. So the reason why we came up with the tubular gel is primarily for its higher cycle life and temperature tolerance. That gives it the advantage for organizations who are into, let's say, independent power producers. Like we are involved in a project with the Myanmar government in Southeast Asia, wherein our batteries, our tubular gel batteries, are installed in their off-grid power segment, and they use it to generate electricity to feed into the grid or sell to the local community. Now, how this works is basically by using a software monitoring system, inverter system that allows the battery to be discharged precisely up to 50% DOD on a daily basis and bring it back up to at least 98% of its capacity. So working upon this, they are able to match the power generation rates that they usually get from fossil fuels or from coal-based power plants. And sometimes it is even cheaper by 2 or 3%.
So it's like a BMS, but without having a BMS.
Yes, correct.
Okay.
It is a programmable inverter that allows you the independence to use the battery as you see fit, something that the lithium-ion battery does not allow you. So just an interesting fact, I'll just take one more minute. I was informed by my R&D head, how exactly the lithium-ion battery came into existence. So if somebody knows how it, they can actually correct me. So the story I was told is that the lithium polymer battery was invented by some scientists who were funded by the US Department of Defense and used the lithium polymer battery for their cruise missiles, for powering the guidance system. And the objective of the cruise missile is to eventually explode and destroy. And they could not have a battery which retards the explosion. Hence, they use lithium polymer battery, which is actually it is actually an explosive in itself. So it aids the explosion and the destructive power of the missile, the cruise missiles. And this is the reason why it is still used in cruise missile guidance systems. So the objective of design, no one thought, that 50 years on, the lithium polymer battery will be used for solar systems. That basically gives it a situation where it is still, that's why you might see it is still quite unsafe for domestic users.
So I'm sure if somebody has a bit more background information about this, they will make sure to share about this in the chat. But I want to move on with more questions from the audience. We have several questions about the environmental aspects of the batteries, and I'll ask you two questions in one. First question coming from Charles is, why would tubular gel be easy to recycle, or at least easier than traditional lead acid? And then a question from Rafael: do you, in your operation and your distribution networks, do you also have the distribution partner that collects back those batteries and can then engage into the recycling activity?
Yeah, so answering the first question, the thing is that as I mentioned, the infrastructure to recycle lead acid batteries already exists on each and every continent. Most of the major economies in Africa have their own recycling plants. It is actually easier to recycle lead gel batteries because, as compared to the flooded conventional batteries, there is no spillage of a dangerous electrolyte. The electrolyte in a conventional flooded battery consists of sulfuric acid that is very corrosive to the skin and dangerous to the human, body. But in a lead gel battery, the electrolyte is basically fixated in the consistency of a hair gel. So it is easier to handle, easier to recycle, same as lead acid, and the same infrastructure can be used to recycle the batteries. That's why it is actually a step further in the ease of recycling. And there would be, as I mentioned, you can easily find recyclers. There is three components here. There is first the polypropylene container, the outside container. Then there is the lead inside the battery. Then there is the electrolyte, which has to be disposed of. So there are existing infrastructure and companies in each country that have capability to recycle such things, and it is very easy to find them.
Thank you very much. Yes, I think recycling capabilities there, it's more like the channel to collect back a multitude of batteries, which is sometimes a bit challenging. But hopefully with more volume, more solutions will be developed. Moving on to some other question, another question from Mohammed. When people are looking into buying batteries, they should of course look at the quality certification of the different brands and the different technologies. But are there any specific standards that are easy for anybody to look for? Because in your presentation, in your slide, for example, you mentioned certifications from many different companies. And I could imagine, I'm playing devil's advocate here a little bit, but I could imagine that the multitude makes it a little bit more confusing for somebody who is not an expert. So what would be your advice for people to make a simple choice?
See, if it depends totally. I'm assuming this is a question about how whether you should choose the tubular gel battery as compared to the lithium. Is that right? So,
or lead acid in general, really like any kind of technology for somebody who needs storage, and yeah, what to look out for, and maybe something which is comparing apples to apples.
Correct. So the thing is that each project would have its own parameters, which are defined in the project document. If it's an off-grid, let's say, for example, if it's an independent power producer meant for feeding solar generated electricity back into the grid, the lithium polymer battery energy storage system will always be in excess of maybe $17 to $18 cost per watt, because of the high input cost of investment in a lithium polymer battery. If I'm assuming you would buy from a globally reputed manufacturer like BYD or Samsung or Hyundai. As compared to that, investing in a lead acid battery or a tubular gel battery, the cost per watt is on average, I'm speaking from our own experience, is under $3 or around $3.5 per watt, which measures up to the project parameters and the cycle life demand that is required for it. So this is something that is very general. It depends totally upon what project you're working on, what is the size, what is the cycle life demand, uh, how much commitment you have for the units, electric units to be fed into the grid. Depends totally upon it. But yes, there are some projects where lithium ion remains the battery of choice due to its higher cycle life. Again, it depends a lot about where you are installing it and what is the application.
Okay, and talking about this, we had another question from Rafael, who, well, it was not really a question, it was more of a comment saying, well, okay, you have this table where you compare the real capex and the cycles and the DOD. Do you have, and maybe not for right now, but for a follow-up discussion with all the listeners,
Sure.
do you have some data about the actual cost per kilowatt hour? Is this some study that you've done to really compare? Because in the end, everybody's interested in kilowatt hours for use on their projects. And how do these three different types then compare?
Yes, so we actually can share a project appraisal system that we worked upon for our project in Southeast Asia. That should give you a good idea about what exactly the cost per watt is for the tubular versus lithium ion battery. Because every project investor does this project appraisal about which battery to invest into. For example, like our project in Myanmar, it is basically having capacity of 9,000 kilowatt uh, requirement. So that translates into roughly 800, 12-volt batteries. So investing that, sinking in that much money into the battery product requires such project appraisals. So we can share that. Till date, we've always seen that the tubular gel comes out on top.
Okay, so that will be interesting
Share
interesting
that
data
right
that
away.
everybody will be looking forward to. I'm looking at the time and I see questions flowing in, but I'm going to take two more questions if that's okay with you, Ashish. And for anybody else, if you still have questions, I invite you to submit them anyway, because we will share them with Ashish, and then you will get a chance to get some follow-up on your questions. So don't feel bad if we do not get a chance to address them now, but there will be a follow-up. Next question for you, Ashish, from Musaope. I'm just reading because I'm not sure I fully understand the question, but I'm sure you will. If we are to include climatic control, is tubular battery still competitive?
By climatic control, I mean you're going to install it into a temperature controlled environment.
That's what I would assume indeed. And
Okay.
Musope, if this is not it, please raise your hand and I'll invite you to come and clarify your question.
Okay, yeah, I understand what he's asking. So thing is, all batteries, all conventional flooded and gel batteries are tested in R&D labs at 25 degrees centigrade. That's how we simulate a controlled test environment. So if the person who is into the project can invest into a temperature controlled room where they install the battery energy storage system and maintain 25 to 26 degree centigrade temperature throughout its service life, then the battery is capable of giving its maximum rated output. Like for example, our highest variant of tubular gel battery, 200 ampere 12 volt, is rated at 2800 cycles at 50% DOD. So this translates to a little over 15 years service life. And this, if you maintain it if you maintain the temperature at 25 to 26 or 27 degrees centigrade, you are very likely to reach this rated cycle life output.
Thank you very much. I have a last question for you, Ashish. I believe it's from Martijn, who is asking your opinion regarding lead carbon batteries. Can you tell us a little bit about this and what they are advantage, disadvantage?
Sure. So lead carbon battery is similar in construction to the conventional flooded or the tubular gel. The only difference is that the what you can say the spine. If you remember the video, there is a spine inside the battery that holds all the active material together. So in our case, it is made of a calcium lead alloy, but in the case of a lead carbon battery, it is made of carbon foam. It is like what you can say, it is like a carbon polymer in a way. So what this does is it allows for higher intercell osmosity that allows for free flow of electrons. And it by that way, it allows for at least a higher cycle life of 10 to 15% as compared to the conventional flooded or the tubular gel type. But the reason why it is still upcoming is the high cost of manufacturing the carbon polymer. So the input cost is very high. That drives up the cost per unit of the energy storage system. And it is not very competitive, but yes, it is in the next 5 to 6 years, it should be where, tubular gel is right now.
Well, thank you very much, Ashish, for such precise explanation and really opening the world and opening our eyes about all the small differences that can have a big impact on our storage needs. There were many more questions. I will share them with you. Thanks to Isabel, Mohammed, and Rene, who are asking about your distribution in Africa specifically, either maybe to work with you or to procure your product. So hopefully that will lead to some interesting conversations. There were also several questions which are very, very technical and specific. So I'm sure you'll be happy to address them offline. Before I let you go, I would like to thank you once again for sharing some knowledge and spending some time with us today. And I would like to thank everybody who was listening and connected today for taking some time off and joining the discussion. Before I will close the stream today, I will leave it on for a few more minutes. If you have some last minute questions, please, this is the moment. And yes, Ashish, thank you once again, and very happy to be in touch. And I hope you enjoyed today's session.
It was a great experience, sir. Thank you for having me.
Thank you, Ashish. Bye-bye.
Bye.
And thank you, everybody, for joining us today. As I said, just a few more moments for submitting your question, and then I will close the stream.